So now I'd like to hone in on these in-between spots, and I'll show you a different technique that uses the texture-based fracturing workflow, but just modifies it a little bit more for this situation. So starting with the trace op, I already have an image that I made ahead of time. So just like you saw earlier at the very beginning of this course, you go into Photoshop, find yourself a nice image. In this case, I found this guy, and I did some levels, made it black and white. And after we do that, we end up with this guy. Now, the difference here is that I want to turn this into curves, and I want to extrude along the curves so that we don't have big old chunks of geometry. We just have planes that we cut with. So 2D planes as opposed to big old 3D objects that we used initially. The way that you can do this is you resample like we did before, so maybe 0.01 or even less than that, 0.005 to whatever resolution you need. And then the trick here is to use the ends SOP. The ends SOP is going to allow you to essentially change that U and V, which is responsible for drawing out the polygon. And if we say unroll with new points, we end up turning all of these into basically little curves that we can play with. Now we have some spots right here that aren't so ideal, these tiny little curves. And so to get rid of that, I'm going to use a connectivity SOP and a measure so that we just measure the parameter of all these small ones, and then we can delete them. So we do that, blast, and let's say at perimeter, if that is, let's say, less than 0.1, go ahead and delete that. This leaves us with the resulting pattern that you see right here. Okay, so that's all good. From here, we can use a extrude polygon, and we can just take this distance and go out and say use the point normal. Now, this is going to create these guys over here, and these guys correlate with the holes that would normally get calculated if you pressed this button right here under filters, the hole faces. And so clicking on this hole faces will give you a more accurate read of that map, but it takes a long time. So we can actually do something better by extruding, saying, oh yeah, here's those hole faces. As for select, we can just say select by 3D connectivity and get rid of those guys. And that's a much faster way of getting rid of the holes. Okay, so that leaves us with this, which is pretty sweet. On that poly extrude, let's also give ourselves some divisions. So let's say 10 divisions on that. Let's also use a transform SOP. And then I'm going to drop down a noise. So an attribute noise where I'll affect P for position, and I'm going to center these values so that we end up with something around there. Turn up the element size though. We don't want this going too insane, but something right around there, and then maybe down on the amplitude is going to create a nice bit of breakup for these planes. Okay, let's also take our transform, scale this up like that, and have this, again, just intersect all of that geometry. So, again, we'll do this sort of thing, bring it down, and I believe this is all we really need for the most part. Let's actually take and hold off on removing these guys until the very end. So now we'll go to our scaled up stuff, and for all these guys, S for select, again, 3D connectivity, and we're going to get rid of those dudes. The nice thing about this is that we can also use this with a combination of flat grids. So if I go right here, scale this up, and let's say, yeah, polygons, we'll do absolute channel reference, and turn this up with a mountain SOP. I could throw in a few of these and have it horizontally intersect everything, and that will add to the fracture as well. So from here, I'll use a mountain, element size up, height upwards, and I want to bring this height so that some of these areas are going above the plane and some of them are below. So I'll turn this up a fair bit, maybe right about there. And also I'll just turn this grid up a few more rows. So let's say 150 on that. And then all you need to do is just take the mountain sop, make a duplicate of that, change the offsets, maybe a couple times here, so that now we have some horizontal cutters. This all merges together, and then eventually we feed this into a Boolean sop where we take the original planes and we fracture that against, we do a shatter. Set B is going to be surface. Do not collapse tiny edges. And let's see what that does. All right, so we got some rocks now. That's looking mighty rocky, if you ask me. Well, that's cool, but what would also be cool is to get rid of these rocks that we don't need, that aren't in the camera, because that'll slow down our sim quite a bit. So I've brought in our volume, and I converted that. Well, I brought it down so that's intersecting with everything, and then I converted that into some polygons, with the trick being to mess around with this ISO value so that it shows up. And then we could just take this Boolean against the in-between sections with a subtract B minus A, and look at that. Now we have everything we need. Okay, so now we take that, we Boolean against everything. That should work much more quickly now, and it should only give us the pieces we really need to have. So now that we have that, we'll eventually want to bring back the old pieces, because for rendering purposes, we still need something over here and over here. So to do that, we just need to take that Boolean, make a copy of it, and then change the operation here to intersect. And I believe if we do intersect and let's see. Yeah, that will give us just the rest of it right there. So we'll create a null for that, and we'll say in between non-frac out. So we'll go right there with that. Now right away, after I fracture something, I'm thinking about the name attributes. What's happening with name? Am I keeping track of it? Well, if we go to the assemble, I said output prefix called in between. So Geo spreadsheets, this is essentially our first fracture. Now, when it comes to calling this a primary or secondary, tertiary, and all that, I judge that based on the scale of the piece. So even though this is the first fracture, I wouldn't really call this a primary fracture. I would call this more of a secondary fracture, and the next level is tertiary. That's the way I organize it in my head. I think more the scale of the pieces themselves, but you're welcome to think of that however you'd like. It's all just kind of organization and how you want to, set everything up for the future. So anyway, we have that going on. That's cool. Let me show you another technique for creating tertiary pieces. There's a really cool thing that you can do, which basically involves using the bounds of each individual piece as you fracture it to get the fracturing geometry. It'll make more sense in the next video, so I'll see you there.